welcome back to our machine design series. Today we are talking about an important aspect of bearings, both rolling element bearings and journal bearings, and that is lubrication. So the object of any lubricant is to reduce friction, wear, and heating of parts that are moving relative to one another. So if we take a look, for example, at our journal bearing, bring up this drawing, and let's say that this bearing is moving, rotating with the speed n in this direction, and of course the housing is fixed in place, then this type of bearing can have two different major classes of lubrication, and maybe it would be helpful to actually take a cross-section view of this. So as this bearing rotates, it is also having an effect on the flow of this lubricant. And depending on the speed of the bearing, depending on the viscosity of the lubricant, and also depending on how much load, which we're going to call W, how much load is on your bearing, you may have a full film lubricant or a boundary film of lubricant. All right, and the way that these two types of lubrication will look on the surface differs. So let's draw what they might look like. If I were to zoom in down here where the two surfaces are close to touching, then for my thick film lubricant, what I might see, I've got surface asperities on the surface of the journal, and I'm also going to have some surface asperities on the surface of the, let's do that again, on the surface of the bushing. For a full film lubricant, there will be a full layer of lubricant, as suggested by the name, that exists between these two surfaces. Okay, so nowhere will these surfaces actually physically contact one another. For the boundary lubrication, on the other hand, here's our surface asperities as before, but now these surfaces will actually physically contact, at least in some locations. There's still going to be some lubricant between these two surfaces, but they will actually be able to physically contact one another, which means that wear is going to be able to occur. Now we have some subtypes of thick film lubricant that we'll talk about. So first off, we have hydrostatic lubrication, and this is a type of lubrication that occurs when we have a continuous supply of high pressure lubricant to surfaces that are sliding against one another. So I will link a video of a very impressive demonstration of an air bearing that was able to move, I believe it was 75 tons, somewhere close to that. And the way this machine works is it simply forces high pressure air out from underneath the pallet through some nozzles, and this high pressure air causes the pallet to actually float just a little bit above the surface. So it forces this lubricant, which is just air in this case, a high pressure air, and allows these surfaces to slide against one another. So it's a really impressive video. This is also the same principle, for example, you see in air hockey tables. So we force pressured air out through the nozzles on the surface of the air hockey table, and that causes the hockey pucks to actually float a little bit above the surface. All right, next let's talk about hydrodynamic lubrication. So hydrodynamic lubrication occurs when we have a sufficient supply of lubricant to allow relative motion of sliding surfaces to pump the lubricant within the gap. So if I take this image, or this drawing, let's just talk about what this looks like. Okay, so for hydrodynamic lubrication, as this shaft rotates with the speed n, the lubricant that is directly on this surface of the shaft is going to move with it, right, at that same speed n. And it's going to come around and actually be forced into this gap between the shaft and the housing at some pressure. And so if you have a high enough speed, a high enough viscosity, or a low enough load to allow it, then this pressure can actually help keep the surfaces separated. And as long as you have a sufficient supply of lubricant, it will continuously pump that lubricant within the gap. All right, and then last but not least, we have elastohydrodynamic lubrication. Hydrodynamic. And this is similar to hydrodynamic lubrication with one additional step that is the pumping of the lubricant within the gap actually causes elastic deformation of the surfaces sliding against one another. So if I take a look again, zoomed in on these surfaces, I have some surface disparities on both the journal and the bushing. Okay, and the pressure of the lubricant in elastohydrodynamic lubrication will actually cause some deformation of these surfaces, so it can widen the gap between the surfaces. You'll hear people talk about elastohydrodynamic lubrication more often when they're talking about rolling element bearings. This is hard elastohydrodynamic lubrication, and that happens when surfaces are in rolling contact. So roller bearings, gears, cam tappets, and so the order of deformation for those surfaces is going to be to do with the size of the contact area that you've learned about in Hertzian mechanics. But elastohydrodynamic lubrication can also occur in journal bearings where the size of the contact region actually extends over a substantial portion of the journal and the bushing. So it can happen in both, although sometimes people will only refer to hard elastohydrodynamic lubrication and say that it must be rolling contact, but that's not completely true. So anyway, if that was confusing, don't worry about it. I'm not going to quiz you on it. Just note from my searches on the internet, things that I've seen. All right, and that's going to wrap it up for this video. Just wanted to go over some of the different types of lubrication that you might see in journal and rolling element bearings. In the next video, we will talk more about lubricants by talking about viscosity and the different grades of oil that are available. And so stay tuned for that, and thanks for watching. Hope to see you in the next one.